Welcome to Unit 8, Lesson 1. This is going to be all about quadrilaterals and polygons. I'm actually going to start at the bottom of page 2 because the first page and a half you should have been able to figure it out on your own, Google it, or talk to a classmate about it. So I'm going to start right at the polygon sum theorem, angle sum theorem. So what you should have discovered if you did the notes in the previous part is that the sum of the measures of the interior angles of an angon, which just means however many sides, is 180 times the number of sides minus 2. So for number 1, if we have a 34-gon, that's just going to be 180 times 34 minus 2. And that is going to be 5,760. And it's as easy as that. For number 2, we need to figure out what's the interior angle needs to be in total. So we got a 1, 2, 3, 4, 5, 6-sided shape, hexagon. So that's going to be 180 and minus 2. And draw that a little prettier. That's going to be 180 and minus 2, which is going to be 186 minus 2. 180 times 4 is going to be 720. So all the angles need to add up to 720. So we got 90 here, 90 up here. So we got 120 plus 90 plus 135 plus 135 plus 90 plus x, and that needs to equal 720. So if you do all that, you figure out that x actually needs to be 150. So that when you add up all the angles, you get 720. Again, not too hard, pretty simple. I'm going to move on to the next page. The corollary to the polygon angle sum theorem, which just says that the measure of each interior angle in a regular angon is 180 times n minus 2, all divided by the number of sides. Okay. So here we have a 20-gon. So that's going to be 180 times 20 minus 2, all divided by 20. So that's going to give you 162 degrees. Okay. Number 4 doesn't, well, it tells you it's a hexagon, a regular hexagon, so that's 6 sides we know. That's going to be 180, 6 minus 2, all over 6, which is going to be 120. So each of the interior angles is 120. So again, regular just means that all the angles are going to be the same. Next, we have the polygon exterior angle theorem, which just says that the sum of the exterior angles of a polygon, one at each vertex, is 360. So if you add up all the exterior angles, you should get 360. The corollary to that is, if the polygon is regular, each exterior angle will be 360 divided by the number of sides. So again, not too hard. So we have a regular decagon, which is 10 sides. Find the measure of each exterior angle. So if we go back to our corollary, we have 360 divided by 10. So each exterior angle should be 36 degrees. 36 times 10 is 360. So it always has to equal 360. If we look at example 6, they give us different measures for our exterior angles, but we know that they all have to equal 360 when you add them up. So we got x plus 2x plus 70 plus 80 plus 60 That all has to equal 360. And when you solve that out, you should get x equals 50. Okay. I want you to try 7 and 8 real quick. Give you a second, and I'm going to put the answers up. Okay, for 7, you should have got x equals 103. And for number 8, you should have got y equals 380 divided by 3. That wouldn't give you a whole number, so you can just leave it like that. I'll do one more example before I let you guys work on the back page, which will be your classwork. So for this example, we're going backwards. So they give us how much each exterior angle is, 18 degrees. And we're trying to figure out how many sides is the shape. So the setup would be 360 over n equals 18. When you have a variable on the bottom of a division problem, what's going to end up happening is that these switch. So you got 360 divided by 18 equals n. So this is actually going to be a 20-sided shape. So 20 equals n. And that's how you find the number of sides given an exterior angle. Okay. You guys can work on the rest of the classwork on your own. I'll have the answers if you want to come check. This was a pretty simple lesson. Hope you enjoyed.